I want to show you how to demonstrate a sum of the form a1 plus a2 plus a3 plus an is equal to bn without using induction. So two examples of this are the sum of the first n integers and the sum of the first n integers squared, although I'm missing a little square on that n there. It should be n squared. So one way to do this is by induction, and certainly if you've taken a proofs class before, then that's probably your best go-to tool. But another way of doing this is by telescoping sums. And for telescoping sums, you just need to show two things: that the difference between the bi and bi minus 1 term is equal to ai, and you also need to show that b0 is equal to 0. So now if we look at the sums a1 plus a2 plus a3 up to an, and we replace ai with bi minus 1, and we write down all of these terms, then we look and we can see that they cancel one by one. b1s cancel, b2s cancels, b3 cancels, b4 cancels, bn minus 1, bn minus 2, and the only things that are left are bn and b0. So how do we apply this in the two examples that we have? So we take the sum of the first n integers. If bn is n times n plus 1 over 2, then bi is I times I plus 1 over 2. And bi minus 1 is I minus 1 times I over 2. And their difference, if we do a little bit of algebra, we show that it's equal to exactly I. And I happens to be equal to ai. It's the ith term in the sum. So we just check that b0 is equal to 0, then this proves by telescoping sums that the sum a1 plus a2 plus up to an is 1 plus 2 up to n, which is equal to bn. So now let's apply this to the other example that we had, the sum of the first n squares. And I said that this was equal to n times n plus 1 times 2n plus 1 over 6. So then we write down what the bith term is, and then we write down what the bith minus first term is, and then we look at their difference. Now, when we compute bi, we expand the numerator and see that it's a polynomial of degree 3. It's got 3 terms. And we expand the numerator of bi minus 1, and it also has 3 terms. And amazingly, 4 of the terms cancel in that sum, and we're left with just 6i squared over 6, and that's equal to I squared, and that I squared is equal to the ith term on the left-hand side. That's your ai. And we can conclude by telescoping sums that the sums of the first n squares is n times n plus 1 times 2n plus 1 over 6.